Welcome to this Explainer. Today, we're going to dive into the staggering amount of physics, design, and metallurgy behind one of the most ubiquitous objects in the world. You probably used one this week, but I can almost guarantee you've never thought about the intense science required to make it snap perfectly every single time. So ask yourself, how much thought have you actually put into that little metal contraption sitting in your bathroom drawer right now? It looks incredibly simple, right? Well, not quite. The Edison AI research project actually categorizes this device under naive mechanics. Basically, to even comprehend how this thing works, their AI had to run complex problem-solving algorithms, what engineers call constraint satisfaction heuristics, literally just to figure out how to make it function without breaking itself. It's this beautiful, intricate dance of force, leverage, and material limits.
Yes, there really is that much complex science behind this tiny object. So buckle up. We're going to cover 4 main areas today: the anatomy of a clipper, the great steel debate, a look inside the factory floor, and finally, finding your perfect match.
Starting right off with Section 1, the anatomy of a clipper, deconstructing the design. Let's totally shatter the illusion of simplicity here and look at what it takes to actually design one of these from scratch. When engineers sit down to model a clipper in CAD software like SolidWorks, they aren't just drawing 2 lines and calling it a day. They are solving a very real mechanical puzzle.
It turns out the constraints they're working with are brilliantly complex. A standard nail clipper is basically a highly specific geometric system. You've got 2 main parts bolted together specifically to provide the necessary leverage to shear through a tough human nail. You have a base connected by a circular shaft that allows a full 360-degree rotation. And the lever arm? It doesn't just sit there randomly. It's engineered to rotate to a highly specific 43-degree angle relative to the main body just to give you maximum mechanical advantage. And then, the upper and lower jaws have to converge at an incredibly precise pivot point.
Now, this brings us to a super crucial concept called the lap. You'd probably assume the top and bottom blades meet perfectly flush, right? Well, wrong. If the blades perfectly aligned, their hard, sharp edges would smash into each other, crushing and dulling almost instantly. So engineers deliberately offset the upper blade from the lower blade by exactly 0.1 millimeters. This displacement, known in the industry as the lap, requires immense subtlety. Think about it. If the gap is smaller, the blade damages itself. But if it's larger, the clipper just bends your nail instead of actually cutting it.
All right, moving on to Section 2, the great steel debate, material showdown. To maintain that crazy precise 0.1 millimeter gap under the massive pressure of human hands, you need some serious metal.
So it all boils down to a classic trade-off between our 2 main contenders, stainless steel and carbon steel. Professional-grade clippers use 420 stainless steel, which complies with ASTM F899 standards. Yes, that literally means surgical grade for a tool sitting right next to your toothbrush. It's entirely rust-proof and highly hygienic, making it the absolute standard for medical and salon use. On the flip side, we have budget-friendly carbon steel. Interestingly, carbon steel actually gives you a harder cutting edge and retains its sharpness a lot longer, but it's incredibly vulnerable to moisture. So to stop it from rusting out in a steamy bathroom, it requires a protective nickel or chrome plating.
But hey, no matter which metal you choose, the thermal engineering is absolutely vital. To prevent the blades from chipping, which, believe it or not, is a surprisingly common complaint even for legacy brands like Victorinox, manufacturers have to hit a highly specific hardness target of 50 to 55 HRC, or Rockwell hardness, during the heat treatment phase. If they miss this target by even a little bit, that perfectly engineered edge will literally shatter under pressure.
And honestly, the material choice genuinely matters in the real world. Just look at this review from a community dedicated to lifelong products. Premium Japanese stainless steel clippers, like the ones from Greenbell or Seki Edge, are widely celebrated because their material integrity allows them to last over 20 years without losing their edge. It's a true testament to getting the metallurgy exactly right.
Which brings us to Section 3, inside the factory floor, global manufacturing. We've talked about the materials and the design, so let's zoom out to the macro level and step inside a state-of-the-art manufacturing facility, like the famous KI factory in Japan, to see how these things are made at scale. Making just one clipper requires an intensely fast-paced, multi-stage process. It starts out rapid, unrolling massive coils of stainless steel right into pressing molds, then joining the upper and lower blades using spot welding. And fun fact, that's a technique commonly used for assembling car bodies. From there, the pace shifts. It enters a thermal furnace at a blistering 1,000 degrees Celsius, gets rapidly cooled to lock in the hardness, and is then shot blasted with high-speed glass beads to smooth out the surface.
Finally, it's meticulously edged on a fine built and heavily inspected.
I absolutely love this little engineering detail. During that extreme thermal process, they actually use high-frequency waves to heat just the area around the weld to 180 degrees Celsius. This selectively softens the steel in that one specific spot so that your clipper's handle acts as a smooth spring, bouncing back open after every single cut. It is an incredible piece of targeted heat engineering.
To keep up with insane global demand, these factories are operating with stunning precision. They utilize in-house robotics like automatic guided vehicles that navigate the floor to transport parts autonomously. Machines are running at a 90% efficiency rate, seamlessly collaborating with the human workforce. For example, some specific production lines track metrics where 200 workers might be timed, producing just 100 highly complex, specialized nail clippers every single hour. And that incredibly low output per worker isn't a flaw. It's actually a reflection of the intense artisanal quality checks required, perfectly balancing handcrafted precision with massive industrial scale. All of this massive behind-the-scenes operation fuels a booming global industry. The United States completely dominates global demand, holding the largest market share along with strong year-over-year growth. However, what's really fascinating here is the rapid expansion in European markets like Germany and the UK. They are showing high growth demand specifically for premium medical-grade tools and eco-friendly packaging. And finally, Section 4, Finding Your Perfect Match, Consumer Choice. Let's bring all this crazy engineering back home to your bathroom cabinet and figure out how to choose the exact right configuration from this massive global market. Because, believe it or not, there's a surprising variety out there, and it's all about matching specific pros and cons to your exact needs. The standard lever type is the easiest to use and great for thick nails, though it can be a bit bulky. Nipper clippers offer true surgical precision for shaping, but they do require more hand strength. Scissor types offer great control, while guillotine styles are super cheap but carry the risk of crushing the nail. And hey, if you have arthritis or limited dexterity, you don't have to struggle at all. There are even electric battery-powered grinders that'll just do the work for you. Here's an awesome insider tip straight from the manufacturers themselves. If you suffer from ingrown nails, you have to be super careful. Standard straight blades simply don't fit the natural curve of the toe, and if you force them, the nail can crack. You should actually seek out specialized clippers engineered with convex blades. Products like the Square Cut allow you to clip the center of the ingrown nail perfectly without damaging any of the delicate surrounding structure.
So, as we wrap up this explainer today, having seen the wild 0.1 millimeter blade gap, the crazy CAD constraints, the 1,000-degree thermal processing, and the meticulous materials science that literally prevents the blade from shattering in your hands, I just have to ask, will you ever look at a simple nail clipper the same way again? I know I won't. The next time you hear that satisfying snap, you're going to know exactly what it took to make it happen. Thanks so much for joining me on this deep dive.